Welcome to another episode of the Data Playbook podcast. It's a podcast for data leaders to help them build data-centric organizations. We do that through a series of interviews with other data leaders, data experts, and data practitioners. The topic of today is the art of the data platform. And I have with me nobody less than Jelle. Jelle, welcome to the podcast.
Thank you.
Before we dive into data platforms, can you quickly introduce yourself?
Yeah, so my name is Jelle. I'm 27 years old. I'm a consultant for Dataminded, and I'm currently leading a client. And there I'm responsible for building and maintaining a data platform. Next to that, I also teach in night school. And one of the courses I teach is Data Essentials. So getting people started with data without having any prior knowledge. So your mom could start that course, for example.
It's a stretch, but okay. And maybe for the people listening who don't know you, you're way too humble. I consider you to be one of the leading thinkers, if not the leading thinker in Dataminded when it comes to data platforms and data architecture. You're opinionated about these topics, and you also not just ranting about them. I think you're very good at bringing together the knowledge of what you learn at clients and what works and what doesn't work. And you're very good at inspiring other clients to, let's say, give them a vision of where they should go with their platforms, right? So that's also why we specifically invited you for this podcast.
Well, thanks for the compliment. Don't know really how to react to that, but...
Just makes you a bit more nervous even.
Yeah, indeed. It increases the pressure.
But let's start with the basics, right? What is a data platform?
Yeah, for me, when you look at data platforms, I mainly see it as an extension of like a developer platform. So developer platform, the goal is to make developers more productive and reduce their cognitive load, so they don't have to be aware about everything that is needed to build something end to end. So some of those things are taken away from them, while they can maximally focus on delivering value. So their unique knowledge that is needed for their company. And that is what a developer platform is. Then a data platform is mainly applying those same principles, but to data. So to data use cases specifically. So of course you need the basics in place, like you need to compute, you need orchestration and so on. But then what else is there additionally to data? For example, for building AI use cases. And that's something that's maybe not needed in a standard software application, but it is for data.
Yeah. You used the word cognitive load. What is the typical cognitive load that you can experience? If I'm a use case developer, I want to build a data use case, I'm a data engineer, data scientist. What is the kind of cognitive load that I have to deal with?
Yeah, so imagine you're the first developer in a company and they want to build something end-to-end and there's nothing in place.
Yeah.
Well, to fully go end-to-end, you probably need to be on the network. And you need to make sure that things are secure. Once you deploy things, you need to have monitoring in place. You need to look at the logs. You need to set up all those servers for all those, for example, orchestrations tools like Airflow. So a lot of things need to be there before your end value is there. So you can learn those things, of course, to go end to end, but you cannot expect that from all your engineers because it's just too much. It doesn't fit in your head. You will forget things. You will not be an expert in those things. So ideally, you're becoming a bit of a domain expert. For example, in the energy sector, you know a lot about what to do with that business knowledge and how to turn that into value and not have to worry about all those additional things that are needed to make it work end to end.
Yeah.
And so that's what a platform does. It tries to take away that cognitive load so that the developer of the use case can focus maximally on that business value.
Yeah. And so it's about removing friction as well then.
Yes.
If you, I don't know if you have an example in your head, but what are the typical, let's say, developers that you see at your clients what are the kind of activities that you think this is something that you should still be responsible for as a developer? We cannot take that away from you. And what are the kind of things that you say, this is something a platform can do for you?
Yeah. So For example, let's say you have a data source in your company, let's say it's Salesforce or SAP, and you have an idea with that. You know, okay, I want to calculate those metrics that can drive my business forward. Well, that knowledge, that modeling that needs to happen, building those aggregations, I think that is typically something that is specific to your industry. That's like the core of what you do. So that should be the activity of the engineers. Another example is when you do machine learning and you calculate forecasts, well, training different models, seeing which one is the best or has the best performance. Well, that's also something that the developers of the company should still do.
Yeah.
But then an example of what they, for example, should not set up from scratch is how to deploy their code. Once they do a commit to a Git repository, well, then ideally a platform could assist in making sure that that code gets built, tested, shipped to production. Once it is in production, that there's monitoring in place, that they can have easy access to the logs, that there's alerting in place. Also, for example, to start that machine learning experiment, they probably want to use a notebook.
Yeah.
And in that notebook, they need access to data. Well, you might want to make it as easy as possible to have access to that data. For example, by automatically having your AWS credentials set up so they don't have to do manual commands or export environment variables and so on. Those are all things that could be automated to reduce that friction.
Yeah, got it. So for you, you're happy when you see the users of your platform have less friction, build use cases faster. At the same time, the world is not perfect, right? So we all know of cases where, especially in the beginning, the platform, you don't. It's not a big bang thing where you say, "Give me 2 years to build the platform." You want to build the platform together with your use cases, right? And then I know there are sometimes friction points where there are engineers who actually love to build everything themselves and they don't want to use your platform. How do you deal with that? How do you force people on the platform? Do you allow them to build their own things? How do you deal with people not wanting to adopt the platform?
Yeah. So the ideal case is that engineers voluntarily adopt your platform because they see that effectively it is the best way to do things and that they want to use it themselves. But of course, there's always engineers out there that say, okay, but I want to do this myself. This is maybe fun technology to play with. So I think one way of dealing with that is like architects that say you have to use this, but that also introduces more friction. So what you want to do is also allow them to diverge a bit of that path you foresee as a platform. You say, okay, we try to make this the easiest way to do things. But if you have a reason to not do that, then go ahead and go do it yourself. And if that works better, then please let us know so we can also take those things into account I put it in the platform way of working. By making your platform optional and by telling people you're free to use it, well, it will make sure that we as platform developers are going to go find out why they're not using the platform. Yeah. So that allows us to keep staying focused on our end users, because the biggest risk out there is building something that people will not use. Yeah. So by making it optional, well, people are not using it by default, so you will go and talk to them and find out why. So I think one important activity of a platform engineer is doing outreach, giving trainings, and just listening to your end user. What are the problems that are facing? And also welcoming that, saying, look, we are here to help you. Bring that message out there constantly. Every time there's like all hands meeting, you say, our job as a platform team is to help you. If something is not working, tell us and we are happy to fix it. Yeah. And that way you get in this kind of collaboration mode. And when they do something, you encourage that. You don't see it as an attack on you as a platform team. And you say, okay, maybe you do it first, they're specifically in your team. And if that works, well, maybe let's scale your impact as well and make that part of the platform so other teams can use your way of working.
Yeah. And are there specific components of a platform that, looking back, you realize users quickly adopt and they love adopting it, like, I don't know, storage or workflow management, I don't know. And are there other parts of a platform that you see engineers being more reluctant to adopt and rather build it out themselves? Is there a pattern?
Yeah, so typically the things that no one finds interesting to build, like alerting, like you need to get an email when something goes wrong. Well, we don't see people building that themselves. It just needs to be in there, and they complain when it's not there. But even when it's not there, they will come to you and ask you to build it, and they will not start building it themselves. While when it's something more fancy, for example, we need a new cluster or a Kubernetes or something like that, then they would like to play with that around. And mainly when they see it's also a technology that could be interesting for my personal career to learn, or something they've read about online. So the more fancy things, not legacy technologies, well, there you have that.
Like vector databases.
Something like that.
All right. A couple of months ago by now, you gave a very good talk internally at Dataminded, where you talked about 5 common mistakes when building a data platform. Maybe let's go over those 5 mistakes. I'm curious what they are, right? So mistake number 1, according to you, is mechanisms, not magic. What is that? Yeah,
so the term platform has become very popular. And with every term that becomes popular, it suffers from something that we call semantic diffusion. So everyone starts giving their own definition of what a platform is, and it's not super clear. So what people tend to do is they take their existing solutions, like ticketing systems, or their existing teams, and they rebrand them to a platform team. So it's just like taking a sticky note and writing platform on it, and then sticking it into something, without really understanding what is behind that, or what is driving a platform, or what is it now that is making this a platform. So what this is about is you need to understand the mechanisms that are in place that make it a platform. So then the next question is, what are those mechanisms? And typically it's there. You have a couple of techniques. It's like reducing choice. So instead of having like 10 options to do something, well, you limit that and you say, okay, and you give clear guidance on those are the things we do in this specific scenario. One other mechanism is meaningful defaults. Like you don't have to fill in all those low-level detailed parameters with encryption mechanism and so on. When you create an S3 bucket with us as a platform team, well, we take care of those things, and you think about the things that are relevant or for our company. So that can depend from company to company, of course. And then maybe a final one is like building abstractions. So like having a wrapper, for example, that makes things easier, having a custom library or framework that abstracts a couple of things. So those are typical mechanisms that make it a platform. And
so according to you, and correct me if I'm wrong, but giving people an empty Databricks workspace or an empty AWS account is not a platform?
No, it's not. Maybe if you think about what do I want to get out of a platform, or what does it need to cover? In theory, if you look at the feature list, they will cover everything.
Yes, they do. Huh?
They do. But that doesn't mean it's set up yet. How I think about that is you should take the end user perspective and think about what are the typical steps that they have to go through to deliver something end to end. So what is the developer lifecycle? And in each of those steps, you could probably use Databricks because they do a lot of things, or Snowflake. But then you can still think about how should I exactly set up my Snowflake to make sure that all the glue, all the integrations are in place. What tools are often used together? If I need data access, maybe as a platform team, I can automatically provision the AWS roles that when data is on S3, I can immediately load it in and so on. So there you can think about that, those kind of things.
Okay. Right. The second common mistake that you mentioned is treating the platform as a bag of tools. Because maybe I can first elaborate on that and then wonder what your opinion is. But indeed, what I see a lot of companies say, well, if you ask them what is your data platform, they come with, well, we're on Azure. We do our notebooks in Databricks, and then we have Azure ML for machine learning, and then we store everything on blob storage. And we have SQL Server or whatever for querying. So it's a bag of tools. And if you want to build a new use case, use those tools, right? Yeah. What's wrong with that approach?
Yeah, so it's a bit related to the previous answer. So also there, in theory, you have everything covered, but you should think about that developer lifecycle.
Yeah.
So how do people use those tools? By when going from idea to delivering something that delivers value in production. So you should, as a platform team, do the integration, build the glue between all those things, and make it easy to progress easily through those steps. And sometimes, actually quite often, that is not the hardest engineering work. But the value of something is not decided by how hard it is to build. It is by how valuable it is to end users. So sometimes just having like, I know, a little Snowflake object or a little Databricks object, like a Snowflake warehouse, for example, with monitoring setup, that's something that is 20 lines of Terraform code, but that's tremendously valuable for end users, while it was not super hard to build. So that's what we call building paved roads, and telling people that if you follow this, all the right things are going to be done for you. So you want to make the right things, the easy things, by building that integration.
And so a paved road for you is, for instance, a common use case I have in my team is I need to ingest data onto the Lakehouse environment.
Yeah.
And then you build a paved road for ingestion. Is that how I should look at it?
Yeah, indeed. Yeah. So if you, for example, you decide ingestion should happen decentrally, so not by one central team. So everybody needs to be able to do ingestion. So it will be part of maybe 80% of the use cases. Then you could foresee a paved road for that to make it easy to connect to common source systems, to make sure that metadata gets captured, that people can easily do modeling, that, for example, if you use dbt to do that the credentials are set up and so on.
Yeah, okay. And the same with, well, you mentioned dbt, like I want to build a typical data pipeline or write a data product using dbt, then you have a dbt paved road that sets up everything and you can focus on building the logic, right?
Yes, exactly. So one example there is foreseeing templates. So common technologies are like cookie cutter or Craft. So you just say template apply. It asks you for a couple of variables, like what is the developer name, library version, maybe dbt version. You do enter, and then it scaffolds the project. And the idea is that is like a Hello World project that works end to end. So if you would commit that just generated scaffolded project, then it would also just deploy that all the way to production. So you already have your thing that where the glue is set up. So that's something you can do as a platform team. And then it's up to the end user to add that unique sauce of your company. So the modeling of that ingested data, that energy data, for example.
All right. The next mistake that you mentioned is building the Grim wrapper. What is a Grim wrapper?
Yeah, so that's something I read about in a great book. It's called Platform Strategy from Gregor Hopp. And it's basically about platform engineers that like to abstract things. So they say, this is quite complex. It involves a lot of components. Let's make that easier. Yeah. And it's a good intention. But what you often see in practice is that, end users don't experience it as something that is easier to use. Mm-hmm. And the reason for that is that there's a lot of things involved in building abstractions. For example, you can write a Python function that maybe only has like one argument. You say, great, you only need to fill in one thing. And the function is called run, for example. Yeah. Just call the run function, everything will happen. But of course, then you need to document a lot. And when something goes wrong, people don't have flexibility to fix things. So building this Grim wrapper is about thinking you build something easier, but actually in practice, it's not easier. It lacks documentation. It does too many things. It has no flexibility. Also, when something goes wrong, you get like hidden internal errors that you maybe even technologies that you didn't even know that you were using. Maybe it's using Spark behind the scenes. You see some Java missing jar log, and you have no idea that you were even using Spark. Yeah.
And what is the alternative? Because on the one side, you say, hey, you cannot do a bag of tools. Don't just expose the tools behind the scenes. At the same time, you say, hey, the Grim wrapper, don't build crappy abstractions around your tools. But then how should I deal with that?
Well, I think building wrappers is not the only solution. Mm-hmm. So you need to be aware that there's multiple things you can do, like restricting the amount of options those defaults, those templates. So those are other things next to building abstractions. And when you build those abstractions, well, then you need to be aware about those pitfalls.
Yeah.
Like when there is failure, well, that doesn't really respect your abstraction. So make sure that when you throw an error message, that it always links back to the abstraction you've built. If you foresee a custom YAML file and some Spark error is thrown in your code, well, then make sure that to tell the end user to what he or she needs to do in that YAML file to fix that code. Or maybe he or she did not request something up front, like a bigger Snowflake warehouse size, and they specified that. Well, then make sure that to say, okay, you can request a new Snowflake warehouse in this using this link to this auto self-service tool, and not just show the Snowflake error with the Python connector, for example.
Exactly. Okay. All right.
Another thing there is that you can build like an illusion. So you give the people the idea that something works very simple, but just the nature of the tool you're using is not that simple. So some details you should not abstract away, because then people think they're using something that is actually not the case. A common example there is, for example, a remote procedure call, so an RPC call.
Yeah.
So imagine you're building a wrapper around a REST API.
Yeah.
And that posts some data somewhere.
Yeah.
Well, if an engineer doesn't know that it does that, well, then the engineer might call it in a for loop and call that 1,000 times. And then suddenly you notice that it's nothing like a local function call, and that you get like those obscure HTTP errors, that you have partial failures, that it goes super slow, you cannot debug locally, and so on. So that's a dangerous illusion.
Yeah. Is that linked to the fourth mistake you mentioned, the linear illusion, or is that something else?
Well, that's something else.
Okay. Can you dive into what is a linear solution according to you?
Yeah. So this mistake was about thinking about how your platform can evolve.
Mm-hmm.
Something you see often is that people do not see platform adoption as a core way in which your platform can evolve. Okay. So what you can do is you can build more features. So say we already supported ingestion and modeling, but now we want to extend the scope of the platform, and we also build AI use cases. So that's like the breadth. How broad does your platform go? You can also say, no, we have a smaller scope, only ingestion, for example, but it's like super deeply integrated. So metadata will be in place, lineage, data access, and so on. Mm-hmm. So that's like a smaller scope, but more depth. So that's already 2 dimensions. Mm-hmm. But the third dimension is end user adoption.
Okay.
And if you think about it that way, so you can picture it like a cube in 3 dimensions, then it forces you also to think about, I'm not building this platform for myself, but I also need users on the platform.
Yeah.
So you can decide where to focus on, and maybe everything you need is already in place, but you say, okay, now this one domain or one department that is already using my platform, well, now I just want to roll my platform also out to this other department or to this other geographical region of my company using the exact same functionality with the exact same depth and breadth I already had. So the risk that you have there is that, especially when you get like big budgets, like a couple of million to start building a platform, is that you don't think about that dimension, the user-based dimension, and you just build. And in the end, you end up with something that people don't want to use or don't get adopted, and you've wasted all this money. So I think it's important to list that user adoption dimension as an explicit one.
And the reason why, if you don't think about the user adoption part, if you think about it too late, then it's harder for new users to adopt your platform, or what is the or you just forget about adopting new users. Or
well, the risk is that you build something that people don't need. A bit like a waterfall versus agile approach. You write out the requirements up front, and then 2 years later, when it's finished, you find out that it's no longer what they need. Also, you never talked to end users. You never got actual feedback. So the risk is that they say, but this is not what I expect, or this is not something I want to use. I don't want to change my way of working to what you just built.
Yeah. So in a way, you say the risk is that you build platforms that are very complete, a lot of features, and also very deep. Like every feature is worked out in depth, and you tick all the boxes, and still nobody adopts it.
Yes, that's one big risk. And a second one is focusing too much on the breadth of your platform.
Yeah.
Because internal developers know that because it's an internal data platform and not some kind of external SaaS tool, that they can put quite a bit of influence or pressure on the platform team. So they have to say basically yes to everything, and it's hard to say no. So your scope gets a bit diluted, and you end up doing everything. So you support a lot of small things, but that also makes you, in a way, the bottleneck.
Yeah.
And you cannot deliver very high quality because you constantly have to switch features. So sometimes it's better to also have a clear vision there. Like this is what the platform does. This is what it doesn't do. And then focus a bit more on that depth and make sure that the things you do, that you do those well, and that you don't do everything.
Yeah.
So those are two common mistakes I see, and how you should balance those three dimensions.
Okay. And then the last mistake you mentioned is a premature platformization.
That's also something that I see all the time. It's also one we still struggle with at the client. And it's about thinking you will need something because you have this vision and you've written out, and we want to end there at some point in time. So you start building a platform component and you say, okay, everybody will need this. We will need this for sure. This will be the next big thing. And then once you build it, you see that, it doesn't get adopted. Or like even 9 months later, no one is using that. So premature platformization is about building something immediately in a generic way without actually validating that you needed it.
And so in a way, for you rather have 3 teams building a new feature, independently without the platform, outside of the platform, before you adopt it in the platform, or how do you deal with avoiding the premature platformization?
Yeah, that's a bit of the concrete example you gave is a bit of a difficult one, because if 3 teams are already saying we need such thing, then maybe it's a good idea to build already in a generic way. But often what is the case is that one team or two small things you have in mind, and then you already built it in a generic way. So how I would deal with that is to take a platform engineer and basically join forces with the team or the developer that needs this new capability, and then build in a specific way first. And that means that either they can do it in their code base if they have all the access rights, but if they don't have all the access rights, and maybe let's say you want to use a new service, Amazon Bedrock, to use GenAI, probably they don't have access to that yet. Well, then you can say, okay, for this one use case, let's give them elevated rights. We don't know anything about this service yet because we haven't used it yet. So let's give them Bedrock star rights, admin rights. You tell them, okay, you do your research, you use it, tell us how it went, what we can learn from it. And if we see, and that's the big if we see that more teams need it, well, then maybe if there's a third time we need to use it, so that's a bit of the golden rule, copy 3 times, then start thinking about generalizing it. Yeah. And often it's the other way around. They say, okay, we make you the bottleneck, you will build it first. Multiple reasons why companies do that. Often because they put quite strong engineers in the platform team, so you think, okay, we give it to them, and then it's in place and other teams can use it. But you have this risk to build things that are not being used. And I often see it come from, also partly ego. Yeah. Let's say, okay, we're a bit smarter than everyone else, and we can anticipate all the users' needs. But then in the end, turns out you made some wrong assumptions that are not the case.
And do you ever quantitatively measure adoption of features at a user, or is it more through interviews and just checking who is doing what? Yeah,
so I think we can definitely still improve a lot on that, but we try to measure adoption of everything we built. Often you immediately see it intuitively, where people ask questions on whether libraries are used, and there's great tools out there that can measure, for example, downloads from private libraries and so on, also templates, so you can see the activity. But also from like user service, like you can check what are you using, what are you not using.
Do you ever measure satisfaction of users? Like, how likely would you recommend the platform?
Yeah, indeed. We should do it, I think, a bit more standardized, like every 3 months or every quarter, or every 6 months.
Yeah.
But we did it already a couple of times. And then you, for example, see, where your weak point lies. Like, as an end user, I have a lot of influence on what gets built in the platform.
Yeah.
That's, for example, something we scored lower on. So they think it's decided from above what gets built. So then you focus on that, like you foresee mechanisms like a sync with the use case teams, or like and make it easier to give feedback, or make it also easier for them to contribute solutions, or make pull requests in the way of working.
I think, as an anecdote, years ago, before you joined the company, we were responsible for building a platform at a client. And I think we made many of the mistakes that you mentioned earlier. And then at some point we launched a survey. And in the end, in essence, we asked everybody who had to use the platform, that's one thing, they had to use the platform, and that was not optional. We also built a lot of leaky abstractions. And then we asked the users of the platform and the people building the platform, the two of them, like, how likely would you recommend the platform to a colleague or a friend?
Yeah.
And there was 0 people who gave it 8, 9, or 10. And that was for us.
Also the builders of the platform.
Yeah. Even the tech lead of the platform would not recommend the platform.
Oh, wow.
Yeah. And that was for us a moment of truth. Like, wait, what are we doing? If nobody likes to build on this and likes to use it, and the people building it would not recommend it, we should stop lying to ourselves. Because indeed, it's a lot ego-driven. It's a lot, if I look back, and I definitely made mistakes there as well. Like, but how hard can it be? We see, because that was the reality, we saw 5 different teams building their use cases on a completely different tech stack. And it's like, this is inefficient, and we can save the company so much money if we only standardize on one common way of working, one platform. Then we'll save the company a lot of money, and we'll go a lot faster. And part of it revolved people who were very happy and productive building Python use cases. We forced them to move everything to Spark. And it was, in hindsight, it was a very, very dumb mistake, because everything was working in Python. And migrating into Spark is a whole lot of work.
Yeah.
And the value add is 0. Well, it was negative because the likelihood of introducing errors was quite high, of course, right?
Yes.
And so we built a lot of resistance.
Yeah, that's funny that you mentioned that, because we had actually something quite similar.
Okay.
So at some point we thought, okay, let's try to move a bit into like a data product architecture, and ideally people use DBT for that. And that's the conclusion we came to. And the reason was DBT brings a lot of structure out of the box, but also like lineage. Like for example, we use Data Hub as a catalog. Well, they have like a connector, a recipe, it's called, to automatically get the DBT lineage also to Data Hub. So we thought, okay, it would be great if every team uses DBT, because then we have all this internal lineage, and then for all the new applications built, we can always trace it back all the way to the source system, which is a problem now in migrating from the legacy thing in the first place, because we don't always know who's using what source in the first place, so what we can turn off or how sensitive it is. Yeah. But then we realized that the platform until that point was mainly built using like Python and PySpark. People have gotten over the years, not from day one, of course, but over the years, they have become very efficient in it. They generated a lot of business value. Yeah. And so we started building our new thing using only supporting DBT, and then it was like, but we will never adopt this if you don't support PySpark with this. so we ended up doing that, and we can still apply some of the principles we wanted with that data product architecture, but not having DBT in place.
Yeah, that's a good lesson indeed. Maybe moving from mistakes a bit to future trends. I think one trend you mentioned earlier is where it used to be focused on, let's say, getting new users on the platform, or getting use cases up to production, if you will.
Yeah.
Now the new challenges you see is, you passed that point, but you see a challenge in the pure volume of use cases and the volume of data and users. Can you walk us a bit about what that is about and how you try to tackle that?
Yeah, indeed. So in the beginning, the goal of the platform was really process, like how do we think about this developer life cycle, and how can we make sure that an idea you have can be deployed to production. So it was about these templates and CI/CD pipelines and so on.
And this typical like experiment, implement, deployment, monitoring, like that
exactly
life cycle.
That loop, and walking through that as fast as possible.
Yeah.
So you set up some kind of factory. First use case is a bit rough, but then you say, okay, but actually on a high level, if you zoom out, 90% of the use cases have to go through these steps. So let's make those easy. That's the core idea. Then at some point, you have a lot of use cases live, and they all consume data and they all produce data. So we saw other challenges pop up that were not or were less a problem when you operate at a smaller scale. So I think it's normal. You shouldn't focus on all these governments in the beginning when there's no value yet. But at some point, you need something to keep it manageable. Yeah. Otherwise, the beast will just grow. So at
which point was it? Like, how many use cases did you have running on the platform when you saw this need?
About 40, 50, something. So
that's a lot, huh?
That's a lot, yeah. But so you basically notice when you open a graph of like all the projects with all the relationship in place, you see there's like this huge graph pop up, and you're like, oh.
You struggle loading it on the web browser.
Exactly. It already takes 3 minutes to load just to know what use cases are in place.
Yeah.
And then you realize that for example, data reuse is lower because people don't know that something already exists. They don't know which value was already delivered on the platform. They don't know who to talk to when they have questions about data. So we started shifting our focus from, okay, we can already move very fast from like an experiment to production, but how can we now improve the process of going from a new idea to a new experiment using all this valuable data that is already in place? Yeah. And that's where data product thinking and building data products came in place. Because the essence is you don't just treat data as a raw asset, as a Snowflake table or a S3 Parquet file, but you try to treat that really as a product. So managing it as a product. So that means you as a producer of that data, you have some additional things you have to do. You have to say, first, I'm the owner. When there's something wrong, I do take ownership. You also provide some stability guarantees. So you say, okay, this is the data I will provide. So this is my schema, my data types, and I will make sure that I will not change that as long as I don't also bump my version. If I do bump my version, then I will talk to every single one of my consumers to make sure that they're aware and that they can update at their time. So those are some critical things. Also like encoding business rules, like saying, okay, but this, I don't know, simple example, this age can never be a negative number, for example. That's an obvious business rule, but in businesses it's often more complex. So you want to write that down and code that so you reduce the chance of assumption mistakes. Because if people just see a Snowflake table, they can easily say, okay, that is what it means, and I will use this for my use case. But then they make assumptions on that data. That is what leads to data quality issues, those assumptions, because those things were not explicitly written down and because the producer did not take this additional ownership. So we tried to move from this raw material to something that is packaged, that has like a quality label, origin, who to contact, what use cases are already using it, and so on. So that, we can also get new ideas faster out there and improve our like standardization of the whole landscape.
That also involves quite a lot of documentation. No? Okay, we say age cannot be a negative number. You need to document that somewhere, right? How do you document everything, or how do you decide where to invest your time and money in? If you have 40 or 50 use cases already, I can imagine you have hundreds, if not thousands of tables.
Yes.
I mean, it's almost impossible to start documenting everything, right? So how do you approach that?
Yeah. So what we mainly do is look at the ownership boundaries. So I think the first level where you really need those documentations in place is once you switch to like a new team that is consuming your data, because you can have multiple use cases in the same team. Well, ideally, you also have that documentation there, but at the very least, when it shifts team, well, that's where they don't have all your knowledge. They are not your domain experts, where you want to have those things in place.
Can you make that a concrete example?
Yeah, so let's say you have an optimization department. Their goal is to optimize energy trading and so on.
Mm-hmm.
And they have meter reading data.
Yeah.
Well, if you need that data also for a retail use case and maybe to do suggestions, well, maybe that data is owned by that optimization team, but the retail team needs to use it for their use case.
Yeah.
So there you want to reduce the chances of assumption. So they need to be aware what is exactly in there and the quality rules and who to contact, so that they don't introduce data quality issues in their retail use case.
So you don't want the retail team to just read the raw meter data without any context.
Exactly. So that's a bit the second part of the answer. It's ownership, but it's mainly about what are the tables, so the final product modeled tables that other teams will use. So you think about it as an interface. Yeah. So all your internal tables, maybe your bronze and silver layers, everything that you use internally to come to that final modeled metered data, well, that you don't necessarily need to protect. That can stay internal because people will not read that. It's only you and your internal team. Yeah. It's what comes out that you say, okay, I'm okay with it if it's used for other use cases. That's what you want to protect. So it's what we call the handover tables. Okay. There you want those additional principles in place. And how that is typically done nowadays is using a data contract. So that formal specification of what the data looks like, well, that's something you encode in what they call a data contract.
Yeah. And I guess you could apply that to all the data sources. So instead of just copying all the raw data from all the data sources to a data lake, you say, no, every data source, if I'm the CRM system or I'm the ERP system, I'm the meter management system, I need to think about which gold tables I expose as an interface to the rest of the organization, right?
Yes. So that's the perfect solution. That is that the operational team, so the owner of that metering system, that they also provide that interface. Yeah. So that means that they're also concerned with analytical use cases and that their manager is aware and that they get time for that and budget for that. And that is usually where the problem lies, is because they have zero incentive to do something for you. And
it's extra work for them.
It's extra work. Maybe they will give you a password to connect to their database and get the data out. But besides that, they're really not involved.
How do you solve that?
Well, that's mainly a cultural issue. That's something you need to solve at organizational level, and it goes quite slow. So there's startups trying to do exactly that. For example, Gable.ai, they call it like data DevOps or data ops, where they say every data table or data gets produced is fundamentally code. So we want to hook into that process, the code that creates data, and apply change management principles on there, so that they also apply this like data as a product, that those interface techniques already in the operational system. So I think that will work in mature organizations where there's lots of software engineers, but usually in like those big enterprises, like old established industries, like energy industry, for example, well, they don't have a lot of software engineers. Yeah. So there, the question becomes, what is the next best thing you can do if they cannot take that ownership? And the answer is that once you ingest the data, so let's say that optimization analytical team, they ingest that metering data, well, they have to be aware that once they model that they also become a producer. Yeah. So you cannot expect something from an operational team if you don't apply those principles yourself in the first place. So we can basically work from right to left and from dashboard all the way to operational system, and then start applying those principles like data contracts, interfaces there, so they can take ownership of that.
No, I think that's a good idea, because that's also something I see going wrong in organizations is when they read, we haven't mentioned the word data mesh yet, but when they read data mesh, one of the first things that the data people say is, that means the responsibility for publishing high quality data to the lakehouse environment or whatever is on the operational teams. It's like, eventually, yes, but that's probably the last thing you're going to do. Like the first thing is you need to deliver value, you need to get business value, business buy-in, leadership buy-in, you need to set up the tooling for them to do so, you need to help them, hold their hand, and eventually you go into a stage where everybody who produces data, including the operational teams, actually take ownership of how to do that and respect the interface and stuff like that, right? But it's probably the last step in the process, right?
Yes, indeed. That's like the final maturity you can achieve. That's like the utopia where you hope to end up one day.
Yeah.
But there's lots of things that make that difficult. Let alone like skills when you learn software engineering, but you don't learn about all those data principles, analytical use cases, and AI. Same is true for data engineers. They don't learn about being a software engineer. So also they're not really aware about each other's world. And that's something that needs to gradually change over time, but it will take a long time. And that's why I think that typically when you read blog posts about data contracts and doing those kind of things, it's usually in very mature digital organizations like digital-only banks or like the Netflix of those worlds that have lots of software engineers. But I think you can already do something by applying those same principles, but then directly after you do the ingestion. Yeah. And eventually you'll build relationship with those teams. And because you are not in full control of when they change something, but at least you can make them aware about all the value their data is bringing. And they can proactively inform you when they are going to make a change and then check what impact that has. So it's not perfect, but it's already a lot.
You mentioned data contracts.
Yeah.
And you described it as like it's the expectations you have of your data, like it should be this format, this and this is possible, this and this is not possible. Is it then the same as a data quality tool, or what is the difference between a data contract and data quality in general?
Yeah, so a data contract is really like a formal specification. It's written down, typically in a YAML file, but doesn't have to be. It's human readable, it's machine readable, and you describe your data. I think that's the fundamental part you do. So it's about columns, data types, and data quality rules. So in that sense, it is what a data quality tool checks. So you want some kind of engine. For example, Soda is a good one that can look at that YAML file. And in that YAML file is also like a link to your data, like the table in Snowflake is called dim customers. Well, then once you run the validation on that data contract, then it will check that table in Snowflake and see whether it is actually the case that what is written down in that contract is in Snowflake. But besides those things, you can also put a lot of other things in there that are not necessarily data quality. For example, data privacy. At some point, you will have to comply with GDPR, for example.
That point is 2018.
Yeah, exactly. And there you could, for example, encode in your data, like this field is personal data.
Yeah.
And you could automatically hash it or blank it or remove it.
Apply whatever business rules you have with regards to personal data.
Yes, so that's not data quality, but it's still something that the platform team could do, is they could read that same data contract YAML file and then make it easy or make it even automatic that the Snowflake column masking policy gets applied to that so that all our consumers don't see that field.
Yeah.
And then you can even allow to define exceptions saying if it's this use case, well, then maybe you can see that use case because it's a valuable use.
Yeah. And does a data contract, does it have to trigger a circuit breaker? So if I don't respect my contract, I don't get to publish my data? Or do you feel like, no, it's a warning is sometimes good enough? Or how do you deal with people breaking the data contracts?
Yeah, so you have multiple ways in terms of raising in maturity. The easiest way is that you have like a central repository somewhere where you say, here, I will put all my contracts. And then you have a process that like every day maybe like loops over all those contracts and then validates it against the actual data.
Yeah.
The problem with that is that it's reactive. So it's possible that for 23 hours and 59 minutes, the data was already wrong and people were using wrong data.
Yeah.
So you can, that's an easy way to start, but ideally what you do is you use a circuit breaker pattern where you validate those things before they become available to consumers. So a way to do that is by using a private place where you store your data. So you say, I do my modeling, can be whatever modeling technique, data vault dimensional modeling, and you say, whatever result comes out, I store them in a place that I will never share with anyone. So like a private schema. Then on that private schema, you validate your data contract. And only when it succeeds, you say, okay, let's now promote that data and make it available in a public place where all the people that got access can read that data. And this way, consumers never get to see bad data. But of course, the negative here is that if there is bad data, they also have no data.
Yeah. Or they have old data, right?
Or they have old data. Yes.
There's a name for that pattern, no? Like write, audit, publish or something?
Yeah, indeed.
It's write, audit, is that?
Write, audit, publish, yeah. So you audit the data before you publish it and make it available.
It doesn't happen a lot. Very often people just run and then run publish automatically because that's like the default is publishing to where the users consume it. And then they realize if the downstream project breaks, we probably messed up, right? And then they go fix it.
Yes, indeed. And sometimes that's even the core activity of what data engineers do is they wait until something breaks and then they go fix it, meaning they have no time for new initiatives and it also limits the scope of what your data landscape can handle.
I have an anecdote there where a while ago we joined a platform team of a new client and the other data engineer said, well, I wonder if you have to be on rotation as well. And I was like, what do you mean being on rotation? It's like, well, yeah. We have some services or pipelines that break every night at 3 a.m. So someone needs every night. Someone needs to log in every night at 3 a.m. to toggle a switch. I don't even know what it was anymore to re-trigger the pipeline so that the pipelines are ready at 7 a.m. every night, right? Wow. As okay, guys, the first thing we're gonna do is whatever that switch is, we're gonna automate it.
Yes. that's crazy, yeah.
Yeah, but reality, right?
Mm-hmm.
Okay. We talked a bit about data products, about data contracts. Are there other topics or technologies that you see are very trending in the data platform landscape today?
Well, what is really coming up now is cloud IDEs.
Okay. What is a cloud IDE?
Yeah, so cloud IDE is basically, so you developers are used to working in an IDE, and nowadays it's often Cursor, where AI does a big part of your job. But also there, people need to install things locally, make sure that the tools are available, that their poetry is set up, their private and virtual environment, that they're connected to AWS, and so on. So a cloud IDE allows to automate that.
Yeah.
Basically says every time you start working on this project, it does that based on a Docker file. So everyone has the same tools installed in the team because that Docker file is stored together with the code. And there is this script that is executed every time that you continue working or like start a new often workspaces that are used for that. And at some point we introduced that in our data platform because we wanted to make that development easier. And it allowed us to throw away basically 20 pages of documentation that people needed to follow to get started and be productive.
And the startup time probably went from 2 days to set up a local IDE to just clicking on the cloud IDE, right?
Exactly, because someone in the team already did it once, or we as a platform even assist with that. So because it's the most for same projects. And indeed, they can now deploy to production from day one. So they onboard, they get put in the right AD groups and so on. They can access the project, they click open workspace, they do commit, an automated CI/CD pipeline, and the changes in production.
Cool.
Yeah, I think that's really nice.
All right. Maybe one final topic I'd like to touch with you is the role of data architecture in data platforms. So how do you look at that?
Yeah, so I think it's important for architects to keep an overview of the whole landscape and see, okay, where will potential problems arise and give guidance on that. And one way to do that is by, not forcing, but like saying, okay, those are the architecture principles that need to be followed. For example, we need to score good in a certain DORA metric, like lead time for changes, like it needs to go fast to get something live. Well, what an architect could do is say, okay, this is important. We will measure that from now on. That can be done on management level. And of course, developers or teams, they will want to improve that because it's now part of their KPIs. So that's where a platform could come in and then very conveniently the platform is the tool that helps to improve that metric. So also there, an architect and a platform team, well, they can very closely collaborate together because they can steer certain behavior. They can nudge people towards the platform by putting architecture principles in place that ideally need to be followed.
Okay, cool, interesting. With that, I think I'd like to wrap up. Before we go, there is always a final question I always ask people. You've been in data for a while now. What is the biggest lesson you've learned in data?
Yes, I think that lesson became clear after going to QCon and seeing a talk from like Sam Newman. He writes the books on microservices. And it's there where he stated that a lot of teams that say they're building platforms, they're really just like imposing limits. They're making things harder. He gave this story of where developers were asking for the cloud. And then the management said, but we already have the cloud. And what turned out to be the case is that they had to make a Jira ticket, fill in the details. And then 2 weeks later, they got like the details about the EC2 machine that got created. So what became clear there is that I was actually also imposing limits in my job on my
building
clients.
data platforms.
In building data platforms. So it was not about enablement. And it's also closely linked to the value of the cloud. Well, the value of the cloud is not about cost saving or imposing limits. It's about the API they offered. It's about how easy it is now. By filling in 5 fields, you have a machine set up in the cloud. And that's also what the goal of a platform is. You should enable rather than impose.
Okay. I think that's a very, very good lesson learned. With that, Jelle, thank you very much for joining us and sharing all the lessons learned in data platforms and giving us a bit of a glimpse of the future. And best of luck at deploying all these ideas at your clients.
Yeah, thanks. And thanks for having me. It was a pleasure talking.